Hello everyone, welcome back to Munro Live. I'm Kevin Hardy. And behind me we have the 2025 Volkswagen ID Buzz. So, before we take a look at it and go underneath the vehicle, I just want to kind of bring some attention to the front. So the vehicle's painted in a two-tone finish. So it goes down the entire body sides itself. One thing to note, painting and masking is it's a very deliberate decision. You can see kind of where they've run their body lines with the vehicle. It's always meant to be this way, but painting and masking is expensive. But it does look pretty cool. As far as the color combination, very retro and kind of modern at the same time. But despite the fact that, there is kind of cost when you do paint and mask, especially on the bodies, when you look at the fascia and kind of how they've layered it, it's pretty simple. And I think in many ways, pretty well executed. So you have essentially this body color fascia here, more than likely painted and sent to the plant itself. And then underneath here, this sub-assembly is probably part of it as well. But you can see just, mold and color black across, and then a separate little piece here, which in this case is probably reasonable, kind of keeps your tool size a little bit lower. You can do a common piece left and right. And one of the things you can also see, right? So you have these two kind of end pieces here that, flank on either side of this front lower fascia. You have your radar here, and then essentially for forward radar, a lot of companies spend a lot of effort to essentially kind of hide this or integrate it or do something like that. Volkswagen just kind of covered it, pushed it, recessed it, and they do bring some attention to it, but kind of like in a disassociated manner, which is pretty efficient from a cost standpoint. Another thing you can kind of see, so right underneath here, you have essentially an energy absorber with your the main impact beam, but it's actually kind of exposed. Eric, if you want to kind of take a look and look straight up, you can see the EPP foam, which is expanded polypropylene. But a lot of people wouldn't expose this for various reasons. They think it looks cheap. But given how low, this vehicle is and where it is, I think it's like an appropriate use of leaving it, exposed, right? Not many people besides us and, your mechanics and stuff like that are going to look at this and take a look at it. So it really doesn't necessarily warrant essentially like a sub fascia closeout or anything like that to improve its appearance. I think it's pretty appropriate as far as being judicious. Another thing you'll note is you can see right into essentially the cooling module from here. There's no active grill shutters. Typically, there's a handful of reasons that you would use active grill shutters, sometimes for actual functional benefit, sometimes because you can get EPA credits for it. And there's kind of a balance on vehicles, their aero performance, and what makes sense as far as doing it. But you can see essentially the cooling module is exposed. They have a small injection molded screen going across for stone impingement, and then essentially more EPP behind that for these leading edges. So, overall, it's kind of one of the few fascias that you can see that far deep into the vehicle where we're actually able to talk about it without pulling off, a bunch of panels. So speaking about panels, again, we have taken off the front. You can see here the threshold for it and mid aero shield. So they are removed. They're sitting off to the side here to let us get a look at essentially, the underside of the vehicle, just so everybody knows that this is not how Volkswagen ships the vehicle. It is covered. So with that note, most of the covers themselves are all injection molded and they kind of fasten in place. On the back side of it, the main, we'll say under motor bay area, they kind of have a PET backing for NVH or noise vibration harshness countermeasures. And that's kind of something you'll see throughout this vehicle where they've kind of used some novel use of other materials. So as we kind of come over here, we'll take a look at crash structure and then kind of work our way down the side here. A little difficult to see, but you do essentially have this lower stanchion coming out from the front of the cradle. It piggybacks off looks like a rolled folded steel piece running cross car. There's another little stamped stanchion running up, and it kind of grabs a stamped steel beam that runs across the motor bay rails themselves. Not a ton as far as deliberate SORB or small overlap rigid barrier countermeasures, but given how wide the rails are and then the offset that we do have above here, they may not need it as well. Or they may be relying on other parts of the body structure to get the performance that they're looking for. This particular vehicle is only rear-wheel drive. They do offer an all-wheel drive version, which has a much smaller drive unit up front. So you'll see some kind of interesting executions with respect to how they flex a vehicle that doesn't have a front drive module in it. So the majority of the cradle is steel, essentially large stamped steel assembly with large weldments kind of going through. Very large and rectangular. Pretty efficient from that perspective. And when you just look at all the materials in general, I think, a pretty good cost-efficient use of materials, in the front end and frankly throughout the entire vehicle. The front suspension here is a McPherson front suspension setup. So you can see the strut and then essentially the valve body go all the way up to the shock towers itself. Now, one thing that's kind of interesting here, and we've talked about this before, single ply control arms, not always possible, but they're doing it on a lower control arm with a McPherson front strut setup, which is pretty, it's uncommon. It is possible, but given to see it on a relatively large EV, it's pretty impressive. They have real tight, deep drawn radius here on the section, and then they're closing this out more than likely for MVH, so you don't get like a whistle or anything like that going across the vehicle, but not real common on vehicles. But again, we are kind of seeing a trend where possible, whether it's like a McPherson front strut setup or a short long setup in the front, of doing single ply control arms and stampings, right? From the get-go, it's a lot cheaper for your program because you're only doing a pair of tools, per side, and maybe depending on what you're doing, you might be able to nest left and right hand side together. So the cast knuckle here kind of has a feature. Now, we've seen things like this before, and we believe it's hard to see if you go like through public images of, let's say, IIHS and their database of photos. But more than likely, this is for a standoff to help control the wheel and its movement, or maybe lock the wheel in a certain particular position. Not only is it supporting the steering system, but you can kind of see here, its shape and its profile. So they've integrated that feature off that provision within a knuckle. But when you look at the size and the material used, there's a lot of material that they do use for this particular feature, which lends credence to the fact that it's probably a crash, part of a crash strategy that they do have. As we kind of come around here, and we'll kind of look up this way here. So again, we don't have a front drive module here. Now, there's not a lot of images, even publicly, about the Volkswagen MEB platforms, specifically the ID Buzz. But on the ones that are available, typically you have a much smaller drive motor up here, kind of a disassociated inverter. And it looks like a casting that runs on the fore part of the inverter, and then another one maybe on the backside. Now, I'd love to get a chance to see an all-wheel drive version here, but you can kind of, looking forward, you see we have essentially this large, structural injection molded piece that is serving as, a bridge across the top part of the cradle and its stanchions, and supporting, your various high voltage accessories for the air conditioning system and cooling module. And you can actually see here, if you look straight up here, Eric, the threshold of the dash panel and how far forward this is, right? It is a bus, kind of in style like that forward control body structure. So that panel, you can see how far forward that threshold is, and how little room they really do have to work with from the perspective of a front drive module. And again, using the strategy of essentially the LASD on everything that would be essentially the leading edge of that dash panel, and on a more conventional vehicle, the transmission tunnel itself. One thing, I try not to be too critical of this because it's difficult to understand whether or not this would change on the all-wheel drive version. If you want to come back over here, is this kind of routing of cooling components here. So we have this, which is not there more than likely on the all-wheel drive versions. I don't know if that's the case for these, but we have this again, pretty structural injection molded carrier that's running down here and piggybacking off the rear of the cradle. EPDM lines, these nice features here that retain these lines throughout essentially the length of the component, and then separate parts. And you have, looks like to be either a valve or a pump on the far side of here. It's a little difficult to feel, but it's at least probably a check valve there. And then it's coming down to essentially some T's and valve and pumps on the back side of the cradle here. When I look at this, I see it's difficult to know, right? Timing, there's a lot going on in vehicle programs, so I'm real sympathetic to why you wouldn't maybe have the time to do something like this. And depending on the take rate of this, maybe there's not a lot of volume for this particular component or assembly. It's only on this particular version, and let's say it's 30% and not worth doing what I'm about to say. But I see this, and I see this as a prime opportunity to essentially do like, blow molded or even an injection molded manifold, right? You vibe all those things together, you get rid of all these assembly features, heavy hose, all those separate components here, and do something that comes down and piggybacks And you might need like a small handoff, depending on what you're doing, of a line between where the hoses mount. But more than likely, this is all built up on top of this cradle assembly. So you would have access where you could essentially kind of build this up, get the pumps, have the pumps brought to it. So it is possibly an area of efficiency gained, for the vehicle in the future. But depending on, again, volume splits, it may not be worth it, right? Especially at this stage. It's already been built up, it's already tooled. There's not a lot you can do about it. But it does give you, probably an interesting insight to how much or how little room they do have based off their current strategy of supplementing other components. And it shows they also are using essentially the all-wheel drive system to help piggyback the support of other components as well. So now on an MQB, which is essentially like the ICE version of this modular toolkit platform, essentially like here at the rockers and essentially your rocker flange, like inboard, roughly to the rear waterfall structure, like the back where you have a kick-up that goes over the rear axle, your motor bay rails, your dash plenum structure, and like your inner cowl to A-pillar handoffs. On the MQB vehicles, those are essentially almost all common. And then if you ever get to see like the assembly plant, that the heads and the body shop rotate through the different variants. So if you have unique fixtures or weld considerations for like an Audi wagon, for instance, versus like a Volkswagen sedan, which is pretty interesting because not only is it a platform, but it's also a plant consideration where everything is modular to rotate through. But there's not a lot of vehicles built on this particular platform, but it'll be interesting as more vehicles are released, how much of those monuments or that area within what was the MQB or still is, if that strategy carries forward to the MEB platform as well. Before we kind of move rearward, you can see here, kind of piggyback of those comments, a mixture of stamped and injection molded brackets, which is pretty, I don't want to say it's unique, but how they're supporting it, it's running across this bracket here, this structure here on the leading edge of the battery. It's captivated in between the body and these shear plates on the cradle, and this as well. So that's kind of interesting from this layering, how this is built up, kind of gives you some insight to like the plant and where this is done, where some of these things are being assembled, kitted up, and sent to the line, and gives a little bit of an insight into the assembly process. Now, as we look down the battery, because we can't really see much, there's this integrated shield. One of the things that we loved about the ID4, and you can see the leading edge of it here, which I think the strategy is still carrying forward for this as well, is their cooling plate is integrated into their housing. So it kind of shares that. That's one whole stack up, one layer of material that they kind of eliminated. And you can see that leading edge here, and then they essentially have this trickle down. And as we kind of look through the rest of the pack, this is essentially an impact shield. This may be a doubler for either core systems or critical systems. I'm not sure, it's a little bit difficult to see, but when you see through some locating pins, they have some 4-ways and 2-way slots here. You can see a little bit of this material being doubled up versus it may, if we were to like cut this off or do a teardown, maybe this is actually not an entire doubled up section. It's open for various reasons. But this essentially shield runs all the way down. You can see fasteners that run through essentially every 300 millimeters or so, spaced out roughly the same, and probably tying into essentially your major cross-car structure running across where both your seat risers are mounted to, and just your complementary structures that you have at essentially B-pillars and your rear essentially seat kick up to get energy to move across the cab and have the battery help support the body and vice versa. But as we kind of look forward, you can see a little bit more of the holes, and essentially they kind of put these teardrop shapes, kind of like a NACA duct, probably to keep from whistling as you drive down the road itself. So they're kind of a neat process. If they're just swaging it, essentially these are probably being, cut, potentially laser cut or pierced, and then, deformed to get the kind of NACA duct shape to it. As we look from the rear of the vehicle looking forward, again, kind of this similar strategy where they have this kind of doghouse coming across the top here, where we have, seems to be coolant lines for the rear drive module, some high voltage control cables as well. Again, piggybacked off between battery structure and in between it and the body. as it runs, as it rearward itself. A little bit more sealing you can see here, and they're only doing it selectively at key joints. Some of these joints are allowed to be wet joints where water and moisture can be present and cleared, but you can see where they kind of sealed wax across here. And again, this is kind of a big thing you see on German vehicles, Audi, or excuse me, like Volkswagen Audi Group vehicles, BMW, Mercedes, all of them essentially do something very, very similar to this, where they do like a wax coating, as you can kind of see here, and then they do a lot of this kind of LASD at critical joints to seal out and prevent corrosion with their body structures. One thing we've kind of always liked again about these packs, is you look across the back here, this one large injection molded piece. So they have a series of fasteners with seals, but and this could be modular, where you have essentially inserts using different inserts with an injection molded tool to get this, but essentially they have one large connector that runs across, and it's common, which is something we don't see often on other vehicles. As we get to this kind of threshold, which I kind of mentioned, like that waterfall kick-up, a very, very large torque box, and again, it is a van, starting to, so this is kind of this rear threshold of body structure where you start to see the pickup of essentially this multi-link trail arm setup that they have here. But the depth is interesting. You start to see some provisions for impact, right? For rear impact here, there's a standoff on the body and on the cradle itself to help maintain distances and help slow down or manage pulse in an impact. But you can see here, essentially we have this trailing arm mounted to the knuckle itself, which appears to be a forging. A lot of steel used out, so very selective use of aluminum, and where they are using it, it's large integrated parts. So from like a value perspective, Volkswagen is getting their money for the material costs that they're paying for. But when you look through here in the back, big, large upper camber arm as well. It's hard to maybe capture on screen, but there's probably, I don't know, 12 to maybe like 15 inches from this rear rail down to the, we'll say the nominal threshold of where this lower control arm would be. This is a very compact setup. And when you look through here in the stay bar packaging, this might be just a new trend that Volkswagen might be doing, but we see a lot of vehicles here. I don't think I've ever seen essentially a welded on like end rod, rod length, if you will, to a sway bar, and then this sleeving over. It's pretty packaging efficient and pretty slick as far as how it packages within the overall control arms itself. And I would imagine, not that this is an overly tight packaging space here, but within these bushings, captivated is probably like an overmolded piece, like a collar, or potentially a steel piece that's like swaged over it and captivated by this bushing to keep the the sway bars from moving forward side to side. But it is extremely compact, and you can just see like the footprint, is essentially, because it does have a trailing arm. If it did have, like I say, a different control arm that was reaching out, it's very, very wide in X, the X direction of the vehicle. Again, because there's just not a lot of room to package vertically, because with these vans, packaging space is key. You could probably load, I don't know if the seats, fold completely flat on this, but when you look at just the body structure perspective, you could probably put enough wood in this thing to physically break the vehicle, given how large their body structures are from like a cabin perspective. Now, another kind of attribute, if you will, of this kind of very wide and splayed out packaging. So you see this leading edge here of the front cradle, and then this integration and like a series of stampings here that they're using to pick up both the drive module mounting. So not only is this used to pick up the this front link here mounting point, but they're also using it to pick up the location for the drive module itself. So again, not a lot of room, so everything is kind of splayed out and kind of smashed on this plane. So and definitely an interesting packaging exercise for sure. You can see if you look from here forward, Eric, again for the upper camber arm, and essentially there's this large NV8 diaper, if you will, that's running all the way across the upper cradle. We saw something similar that appears to be fibrous and like PET. We saw something similar on the Mercedes EQS on the front some time ago, but you can see how tight that camber arm is to that mat, and then frankly to the engine bay rail there as well. So again, very, very compact packaging of the overall multi-link trailing setup that they have here. So A lot of times, when we get to the rear of the vehicle, you'll oftentimes see some things change as far as the complexity of the suspension, but where it'll err on the side of simpler, but that's not necessarily the case here. Clearly with the drive module being, biasing the rear of the vehicle and probably some other driving attributes that they're trying to get, they have spent time and money to package, this system in the back itself. And again, a little bit of impact protection here for this one particular connector that they've added. Now it's hard to know for sure, but I'm pretty sure this is the drive module that we tore down before and Paul's gone through in pretty great detail. So if you want a little bit more information about that, you can kind of reference it. But overall, it's kind of an offset gearbox. You have the differential here. Again, when we kind of get into like the packaging constraints or considerations, this offset gearbox versus being concentric, it drives, X packaging width as far as the vehicle is concerned. And, it does take up a larger packaging space claim. And then you have essentially the lay shaft, running across, which is partially exposed here on the backside. So they're doing like kind of a nice and simple pan closeout. Sometimes we see castings here, sometimes we see stampings here. This is a very subtle aluminum stamping. It'll be interesting to see in a year or two if they switch to steel to try and get some cost out. But overall, similar to what we saw up front, but as far as, there's a lot of steel being used here. You can see how again, I can't stress how tight like the packaging. There's so much happening in such a little space here. It's a lot of work. I can't stress enough with various meetings that we sit in, at times, how much work would go into fighting over this packaging space claim here and what one system wanted versus another, because you have cooling lines running through here, there's high voltage coming up, a harness that's probably running down the extruded rocker sill. Actually, we'll take a look on the other side. I bet you we could probably see a little bit better. But they had this trough here that's kind of locating some of these systems. So you're gonna have, a clash of systems here from body, wiring, exterior systems, right? Because you got cladding all fighting over that space and what they want to do with it. So let's take a quick look here, if we can see. Yeah, if you can maybe go up high and look forward, Eric, you might be able to see just the extrusions. So more than likely, this side of the body structure is probably, mirrored on the far side, and then they're running some of that stuff down the extruded sections potentially as well, or it's unique on that side and versus running them in the extrusions, maybe they're running down the valley or outside the extrusions itself. You can see here we have essentially just a hitch cutout, and it's just a simple stamped steel bumper, like a W form here, and then above it just an injection molded energy absorber, which you can kind of see here with that wave structure. And then, not a lot of room, but there's a fair amount given essentially the leading edge of your Class A surfaces here to kind of absorb impact for rear end collisions. Unfortunately, with these type of vehicles, there's just not a lot you can do with them being this shallow and getting into, more expensive bits as far as when you start exceeding those 5 to 10 mile per hour impacts before you're into a lift gate or the main body structure, which is not that far from the drive module itself. One thing what we can't really see too well, what is packaged behind here, essentially you can see the thickness of the gauge of the material. If I had to guess, probably somewhere in like the 2.5 to 3 millimeters, but it's wrapped around another module, protecting it. So you have kind of that stack up from the body threshold, forward here, then to the cradle itself, drive module, front end of cradle. Again, we have these standoffs here to the body. So there's kind of this whole strategy you can see of how everything is disassociated, but kind of knows itself from the perspective of rear impact. So I'm actually kind of surprised about this. So, one thing that we run into a lot, right, as the industry moves one particular direction. So let's say to disc brakes, sometimes drum brakes, despite the fact that they oftentimes were cheaper, get to the point where there's not enough supply base in the industry to do them, and they start to get more expensive. We've heard this a time or two with respect to leaf springs. So if you're not already like in the know and have the volume and the capacity for leaf springs, so really, this time it's like Ford and Chevrolet here in North America that do a lot of leaf spring volume. If you wanted to kind of get into that area, it's a little bit more difficult because there's not a ton of capacity, because a lot of other vehicles have shifted over to multi-links or different styles of suspension, especially the body-on-frame versions of those vehicles, right? Your Suburbans, your Tahoes, Expeditions, and such. The Wagoneer, all those essentially have either linked solid axles, or now I think almost all have gone to independent rear suspensions. So that capacity kind of dries up. So it is interesting to see that they're doing a rear drum brake and with an MGU on it, right? So it's got a motor gear unit for the electronic park brake as well. So that's an interesting handoff or change there. But maybe we'll see more of this down the line. We've seen a lot of interesting conversations where older versions of technology or another take on something that we used to do a lot of industry is coming back. So, and maybe we'll see more with drum brakes in the rear.
Why is it so rusty already?
So it's kind of a deliberate decision. Again, we're seeing kind of a trend of this. A lot of times you'd see these being painted, right, to prevent that kind of rot corrosion. But it's expensive. So you're probably talking anywhere, like for these ends, somewhere probably between like 50 cents to maybe a little over $1, per section to do maybe the whole axle. Probably somewhere in the range of 2.5 plus, for this section. So it wouldn't surprise me that this isn't done. And then because of how high it is from an appearance perspective, like your studio and marketing folks would be okay with something like this. And then these control arms, since they're a little bit easier potentially to see, or if it was up on a hoist like this, from the back, you'd still see them being painted. And they also get a lot more exposure to the elements. But it wouldn't surprise me, if we saw like in a year or two that these were left raw. Realistically, yeah, it doesn't look good, but the material thickness and grade is enough that it'll be here for a long time where most of us aren't, But that's why it's cost. So you'll see that quite often on trucks and axle assemblies when they're thick and they have a lot of material. So did we miss anything else, you think? Overall, this has been kind of refreshing to see because it's very different. It's similar in the overall execution to many of the Kias and other things that we've seen come through here. But being a van, right? It drives many unique packaging considerations, and we just haven't had a van come through here in some time. Now, this is kind of conventional for that perspective, but not with a lot of the vehicles we've seen come through our doors here recently. So it does provide kind of an interesting insight from like your architectural handoffs and trade-offs that you have to do to deliver a vehicle like this, because it's similar, but maybe we could get another one and then maybe have like an ID4 or an Audi and just show how different, despite being on similar platforms, a vehicle like this ends up being given just the requirements that the cabin size drives. So hopefully you guys kind of enjoyed like a first peek here at the ID buzz, and stay tuned. There's some other videos that we're going to have with it, and we appreciate the time. Thank you.